The Build Show today coming to you from the J.J. Pickle Research Center here at the University of Texas in Austin. I got with me Trevor Brown from J.E. Dunn. Trevor, awesome work today. This is a incredible conference by the Building Enclosure Council, which is part of AIA Austin. And Trevor made all these exterior displays that you're about to see on the Build Show today happen. Now, Trevor, we've got 4 stations we're going to look at today, right? Can you give me the quick intro on what we're going to look at today?
Yeah, the one behind us right now is kind of our burn wall. We're taking typical construction materials and lighting them on fire and seeing how it burns, how they smoke, and whether or not they keep burning or put themselves out.
Yep.
Now we've got a station for air barriers, and we've got a blower door test running, and we have a product called Aero Barrier or Aero Seal. Sealing leaks in the building as it's going. The other mock-up station is all water testing, so our performance water testing that we typically perform in the field. So we've got electronic leak detections for roofs and hot applied waterproofing systems, chamber testing, nozzle testing, and then we're also doing some adhesion testing on the liquid applied products.
Love it, Trevor.
And then the last station.
Oh, I forgot about the last
station is soils. A lot of people forget about the dirt.
Dirt's important.
Yeah, so we got compaction tests, we've got plasticity index, liquid limit, how to classify the soils, what the borings look like. So it's pretty interesting.
So we're going to give you a little bit of a glimpse on all these hands-on tests that Trevor and the rest of the board of the BEC put together. Let's start with fire.
When we're doing construction projects, we typically will have welders accidentally light this stuff on fire. So it's going to be in this type of condition, and we're going to accidentally burn it out in the field. So we wanted you guys to see, how it ignites, how much smoke it puts off, does it self-extinguish, those types of things, because they're all common construction materials that we use. We also know this is polyiso. We know it goes on the roof, not in the wall. But for the purposes of the burn test, that's what we're doing. All right? Yeah. Oh, yeah, absolutely. So we have 2 butyl-based peel and stick products, 2 asphaltic-based products, a polyurethane sealant, a silicone sealant, some Class A polyiso with foil facer. And then up on the wall, we've got rock wool, EPS foam, which you'll see in EIFS projects. And then we've got the pink board and the blue board. These are both XPS insulation products, and the polyiso, Class B. And then we've got some TPO strips up here. This is the type of roofing we see the majority of the time in commercial construction, so we're going to burn that as well. So right now, Lyndon's getting the weed burner going. So it's just a regular weed burning torch. He's going to put the flame on there for a few seconds, and you guys will see how it lights up. So usually the plastic facer is going to light up pretty quick. Keep going on the other side. And with petroleum-based products, they will go up. They'll light up pretty quick. So, and then hit the other ones. Oh, you already got those. Go for the sealants now. So the darker gray material is the polyurethane. The white is the silicone. And you can see the difference between a polyurethane sealant and a silicone sealant.
Polyurethane on the right?
This is the bigger glob of stuff. Yeah, that's the polyurethane. And go ahead with the polyiso. Now the sample in the middle, we only had one. It is a foil face. It's going to perform a little bit better when you hit the front, but we only had one sample, so that's all we can burn today for that material. Go ahead. So I think most of us know that rock wool is a non-combustible material. We see it a lot in the cavity walls, behind metal panels, behind stone, behind brick. Use it a lot in curtain wall applications and spandrel glass. Go ahead, keep on that one for a minute. Yeah, so that one's always going to perform well in a burn test. All right, go ahead for the big stuff. So the EPS foam is styrofoam. It does light on fire really quick. This is how I start my farm fires. A little gasoline and some insulation, and I'm telling you, after a good rain, it'll keep it going. So you have to burn the brush piles down. And then the XPS products, we use these in cavity wall applications as well, behind metal panels, behind brick, behind stone. And you can see the pink board and the blue board are they're the same type of product, just different manufacturers. And then the polyiso insulation, it does have a paper facer, and it does burn very, very fast. A little bit. There you go. And then similar performance on the blue board and the pink board. And then you want to hit that, you might as well get that one. Go back to the rock wool and hit that TPO strip. And then TPO is a plastic material, so once it does light on fire, it'll typically stay on fire until we put it out.
Tests are done. Trevor did a great job narrating, but let's look at this. The rock wool, look at that. Did real well. No flames on that whatsoever. The TPO, on the other hand, on top, which is a thermofoil plastic, caught fire and stayed fire. I thought that was interesting what Trevor said. It's kind of interesting. We got several different flashing materials. The aluminum facing, even though that's an asphaltic product, the aluminum helped protect that from catching fire. And then we had a polyurethane and we had a silicone. And look at that, the polyurethane scorched. Looks to me like that silicone's barely touched. On the polyiso insulation, again, of the foil face, that helped protect it. The paper facing went up, and of course, EPS, XPS, polyiso, XPS, all those lit up. Those need to be protected from fire, right? We're gonna need to put those into an assembly that they're not gonna be exposed to fire. All right, Trevor, next up, we got this big box behind us. What are we demonstrating here?
Yeah, how to build the most complicated deer blind you can figure out.
That's what it looks like.
Yeah. So we're doing an air leakage test with a blower door assembly and then also running the aero seal or aero barrier product through it.
Okay, so you got a blower door test, or you got a blower door going on this
blower
side.
Blower door assembly right there.
Of the shed. He's blowing in. He's also got the air barrier guys here, which is Sean Harris, the owner of Air Barrier of Austin. And then you've got what? A different air barrier and WRB on it around the side? Is that what's going on?
So on this front wall, we've got a Henry product with their metal clad flashing.
Okay.
And just a standard storefront window.
Gotcha.
We left the caulk joints out so you could see how much siliconized sealant's coming out.
So that's what's going on there is you got sealant leaking out. And then what's this, talk to me about the bug screen you got going right here, Trevor.
Yeah, so we cut out a hole and just put some screen mesh up so you can see how much material would build up.
And this screen was empty before, right?
Completely empty. It looked like a normal window screen.
And how long did it take for it to get to this condition?
About 45 minutes to an hour to get to that condition.
That's amazing. And that shows the power of air barrier being able to tighten up those leaks. Let's walk around the side and see what else we've got for WRB materials back here. This is Tremco's Exo Air 430, which is a pre-coated gypsum. I kind of think of that as the zip sheathing of the commercial world.
That's correct.
And then they've got all their details as well. And 110, gotcha, there you go. And then this is
also a beauty-based product.
Yep. And this is, what product is this? It's caulking, do you remember?
Typically we use Dimonic 100.
That's right, it's Dimonic. That's right, gotcha. Now over here we've got Zip System, which I'm actually using on my house currently. Now this is a cool demonstration. Talk to me about what these holes are showing.
Yeah, so aero barrier will seal up to a 1/2 inch diameter hole. So if you have some penetrations in your building that you didn't intend to have, this product's going to find those leaks when it's overpressurized in the building, and it's going to start to seal those holes up.
Wow.
So you see we put several 1/2 inch diameter holes in the building.
So that white that you're seeing in there, that's actually the aero barrier sealing up, and you can see it hasn't quite sealed this hole yet right here, but it's real close to sealing it up totally. That is cool, isn't it? All right, and we got at the backside now, Trevor.
product over here, we've got the ExoAir 230. It's also a Tremco product. What they're flashing, it's a ExoAir 110 AT.
Okay.
And then making the transition, we've got Vapor Shields UV stable, vapor permeable.
Got it. So this is a black meant for an open joint rain screen cladding.
That's correct.
And what's the silver product? That looks like Illumiflash by Polywall, but I don't think it is it?
No, this is Vapor Shield's new stainless steel butyl-based flashing. So it's a flexible membrane flashing that you can apply in a cavity wall application, or here we're using it as a transition material.
That's really cool. Trevor, great job. I know it took a bunch of your time getting this built and designed. Well done. What's our next station to hit, Trevor?
Our next station, we're going to go to water testing.
All right, water. We'll see you over there. Hey guys, y'all know Building Science Fight Club on Instagram, right? This is her in person. Huge honor to have Christine here at the BEC event. All right, Christine, you're narrating the water station for us. What do we got here? You are the king of water, for sure.
So
tell me about these tests.
We are about to look at a test being performed that I actually don't. I see this test misused more often than I see it used correctly.
Oh, interesting.
This is an ASTM E1105. They call it E1105 testing. And this is a test method that was established to test the water holdout capacity of windows that have been installed in the field. So this is a window test. This is not a wall test. It is a window test.
Gotcha.
This is used a lot to test walls, which is problematic in that we don't have there is no agreed upon single standard failure criteria for walls. What is the water holdout of a wall without, especially with, what are we missing in this?
All the cladding's not on,
The
right?
cladding's not on. So how can we test something when we're missing half of the assembly?
Yeah.
And it's not so much, the problem isn't so much performing the test. The problem is more what we're seeking to actually learn from that test. So from an educational standpoint and a diagnostic standpoint, this is an extremely valuable test to do, which is why we're here today to learn more about how different systems behave under different conditions. So it's great to learn about what water does when we put it on a wall, what potential pathways are, and to kind of calibrate your own senses. Sort of like what we did at the fire test over there, where we're not going to install materials
bare
that burn.
foam.
Like exactly, we're not going
Right.
to do that. But it helps to kind of see, okay, when this is exposed to a fire, what happens?
I should know this.
When exactly? Right. I should have a sense of what this actually looks like. So we're going to turn the water on and take a look at.
Actually, Trinidad, I had Trinidad set up the AMA 501.2 first.
Okay.
And Christine, can you tell us generally about this test compared to this test?
I mean, they're the same in that they apply water at a particular calibrated rate to a wall.
Okay.
This one is typically used to test joints as opposed to testing something of kind of bigger surface areas.
Gotcha.
But
And so Trinidad from Terracon is going to use the spray wand here. Go ahead and give us a start on this, brother. All right, now interesting to note here, we've got a Huber zip wall assembly, and at the base of the wall, they use the base wall flashing. That's their liquid flash that they're flashing, kind of like maybe it was a brick pocket down there. They're also, I see they've over-penetrated a couple of their screws, so that's kind of interesting to see. They're past the green facer there. And then they're using a pretty standard flashing tape from Huber, which is their acrylic tape that we've seen perform really well over time. But this is basically a barrier method of install on the window, right? Because we've got a window that's taped all the way around.
The point of this is to demonstrate how you do the test, not to demonstrate how to install a window.
All right, this is not to me.
Install your window.
Exactly.
That's right.
Exactly.
So we rarely use this kind of test method for assemblies like this. Where you see this used most often is in commercial buildings when you're testing face sealed systems. For example, I don't know, structural glazing, where that sealant joint is the end all and be all, and you want to test just that joint.
Right.
So this is a really effective test at putting water just at that joint. You can do this if you do the same test with a non-calibrated nozzle,
Just a hose.
a garden hose. You can do that test, but you have to call it a modified on the 501 test. So you'll see this test written into specifications for commercial buildings, and what they'll do is they'll say, okay, for every X amount of linear feet of sealant of this particular joint, we want to test 100 linear feet of sealant. And it's a way of understanding, it answers the question, do I have a pervasive problem on my building? You're not going to test every single part of it, but you want to know, hey, or it's one of the ways that we can say, is there a defect in the product that I'm using here? Have I used the right kind of primer for this application? Is there something pervasive that I'm missing? And
or is it generally working?
Exactly. So the idea, this is never, ever, and none of these tests are meant to take the place of visual inspection. Most of these things, like the best way to know how that window is going to perform is to go and look at how it's installed. The test is to help us, not to take the place of our good sense and good judgment.
Smart. I like it. All right, Christina, on the next test, what would you use this one for?
I would only use it to learn.
Okay.
I would not use this in a real setting. I might use it as an investigation tool or an illustration tool to for example, suppose I know that something is already failing and I need to illustrate it to a client or to a courtroom or something like that. But this test is on walls, is of very little value beyond education. For windows, this is the way we test windows for their water holdout capacity. It's similar to a test that we do in labs to the same end, to see, okay, this actual window that I've purchased, what's its water holdout capacity under different stress settings.
Got it. All right, Trevor, we're on the last station, Earth. Talk to me about what we're demonstrating here.
So right here we're trying to simulate soil drainage around the structure.
Okay.
So over here we've got kind of more of a pea gravel mix. Water should flow through pretty well. You can see this one's flooded right now with a sand bed, and you can see how it's draining here. And then the one right in front of you, this one is to simulate kind of a clay cap. And we're starting to see more of this on buildings where you've got your drain layer. And then we'll put a clay cap to kind of keep water away from the structure. Now in the front, we've got simulated below grade waterproofing, either blindside or post applied. And we put a T in there, which is similar to this.
So this is the assembly, and this is this looks like Polywall's Arroyo system, if you can see that. So it's a fatter dimple mat here, a thinner dimple mat. We got a filter fabric here, and then there's a drain outlet, and that's what's inside here, right?
Correct. So the drain outlet is for your subsurface draining or your below grade draining.
Gotcha.
And then up on the top, you can just kind of see how the water sits in there. And with hydrostatic pressure buildup, if you start to open up the wall or you get a leak in the wall, this one's not quite going.
Gotta hold that.
There you go. But this is where you're going to get the leaks in your waterproofing membrane. And if you've got enough pressure behind it, you'll be able to find all those. This is where we've got to come back and fix things.
But if you don't have hydrostatic pressure, you shouldn't have a leak, right?
That's right. Yeah, you won't see it.
With the idea being, even if you have a hole in your waterproofing membrane, but if this dimple mat's working like it should, and you're draining at the bottom, you shouldn't have that, right? So if we open this,
so if you open up the drain, and then you try to open up the leak.
If that drain's working properly, it shouldn't leak.
Right.
And actually, you can see that leak stopping right there, right?
Yeah, and as the water gets past that point too, and it's going to drain out faster.
Yeah, that's pretty cool. So this would be like, this is our French drain system with a sump pit.
Correct.
It's lower, we're pumping that water out, and then that gap, that air gap is critical below grade.
Yeah.
That's cool. I like it. Hey guys, thanks for joining me at this BEC event. A lot of good building science knowledge. Joe Seabrook spoke this morning. Matt Carlton and the guys from WJE. Great event. And of course, all this afternoon, Trevor, you did an amazing job of getting this all together. You and the guys at JE Dunn. Anybody you need to thank for their help?
Yeah, absolutely. I want to thank the folks on the BEC board and the Leadership Council for helping put the event together. Chamberlain Roofing and Waterproofing, for letting me invade their space and build all the mock-ups.
Yeah.
S&D Glass for building some some windows for us, and actually installing them as well. So
good stuff, man.
Great event, but I couldn't have done it without the help of all those guys.
Appreciate the navigated tour, Trevor.
Yeah,
great
absolutely.
job, dude.
Good seeing you
guys. If you're not currently a subscriber, hit that subscribe button below. We've got new content every Tuesday and every Friday. Follow me on Twitter and Instagram. Otherwise, we'll see you next time on The Build Show.